Hello everyone. So today we are going to start with the second part of chapter number 8, motion. In this part we are going to cover the following topics: uniform motion and non-uniform motion, speed and average speed, velocity and average velocity, and then few numericals on speed and velocity. So watch the video till end. Yeah. Now our first topic is uniform motion. The definition says that if a body travels equal distance in equal interval of time, then it is said to be uniform motion. Okay. Let us take an example. Example is, if a moving vehicle covers equal distance of 4 meter every second, then the motion of vehicle is called uniform motion. Here in this figure we can see that earlier the vehicle was at point O, then it reached point A, then it reached point B, and then at C. Okay. The time taken for the vehicle to reach from point O to point A is 2 seconds. Again from point A to point B it took 2 seconds, and again it took 2 seconds. It means the time interval is same, that is 2 seconds. And what about the distance? Here it was from 0 to 4 meter, means the distance covered is 4 meter. Then here it is 8 meter, means again the distance covered from A to B is 4 meter, and from again 8 to 12 means again it is 4 meter. Okay, it shows that the distance covered is also equal, that is 4 meter, and the time taken is also equal, that is 2 seconds. So such a motion where both the things remains equal, such motion is known as uniform motion. Another example is of movement of hands of clock. Okay, we can choose any one hand. If we are, suppose let us choose this minute hand. Now we know that in every 5 minutes, if suppose a minute hand is at 9, if it is at 9, then in the next 5 minutes it will reach 10. In next 5 minutes it will reach 11. It means what? It is covering equal distance. Okay, it always moves from one number to another number, or we say the next number, in the same time interval, that is 5 minutes. So such motions are known as uniform motions. You can give your example, just think an example and give your example in the comment box. Now the next motion is non-uniform motion. The definition says that if a body travels unequal distance in equal interval of time, then such motion is known as non-uniform motion. So here what is a change? The change is here, the distance is unequal. Let us take an example. The first example is, a vehicle covers 50 meter in the first 10 seconds, then 90 meter in next 10 seconds, then 180 meter in next 10 seconds, that is third 10 seconds. Okay, let us understand within this figure. Okay, here we can see that the time interval between each slot is same. It is 0 to 10, that is 10 seconds, then 10 to 20, then 20 to 30. It means the time interval is 10 seconds. Okay, now let us see what is the distance covered. In the first 10 seconds it covered 50 meter, then 90 meter, then 180 meter, then 230 meter. So we can see that the distance covered in each 10 seconds is unequal. So such motion where the distance covered is unequal but the time remains equal, such motion is known as non-uniform motion. The another example of can be an athlete who is running a race. Okay, in this figure we can see an athlete who is running a race. Now just think of a relay race, okay, where the athlete run for a 400-meter race. So in that, what does the athlete does? They starts with a low speed, and at the end of the race they increases their speeds. It means what? They are increasing their speed, means they are covering more distance in less time. So we can say that they covers unequal distance in equal interval of time. Okay, so this was an example of non-uniform motion. Again, you can think an example and comment your example in a comment box. Now let us say what is speed. The definition of speed is the total distance traveled by an object in the time interval during which the motion takes place. Okay, and the SI unit of speed is meter per second, that can be written as m/s. So from the definition it can be written as speed is equals to distance traveled by time taken, and we know that the distance is always measured in meter. Okay, and time is measured in second, therefore the unit becomes meter per second. And this can be written mathematically as v equals to s by t, where s denotes the distance covered by the body, t denotes the time taken by the body, and v is the speed of the body. Just don't get confused here, though we are saying speed, but we are using v for denoting this speed, whereas s is used for denoting the distance. Okay, now what is the use of the speed? This speed gives us an idea about how slow or fast an object is or a body is moving. Okay, we are saying that between two cars or two bikes, this car moves fast or this bike moves fast. So actually we are comparing their speeds. Okay, so it gives an idea about whether a body is slow or fast. Okay, now even the speeds are of two types. It can be average speed or it can be instantaneous speed. Okay, now let us understand how we can calculate average speed. The formula to find average speed is total distance traveled by total time taken. Now what is the need to calculate this average speed? Suppose you are driving a car from uh, from Mumbai to Surat, from Mumbai to Surat, and you have to cover few hundred kilometers. Okay, let us say that you covered 400 kilometer. You covered 400 kilometer in uh, in 4 hours. Okay, in 4 hours. So the average speed would be 100 kilometer per hour. Okay, so the average speed of your car becomes 100 kilometer per hour. So this is known as the average speed. For example, you might have heard that the speed of this train, a particular train, is 60 kilometer per hour, or it is 150 kilometer per hour, or usually we have heard about bullet train. Their speeds are more than 200 or 300 kilometer per hour. So these are their average speeds. Okay, so uh, by this we can calculate the average speed by dividing the total distance by total time. Now what is the instantaneous speed? Suppose while driving from Mumbai to Surat, okay, though your average speed is 100 km per hour, but it doesn't mean that you were continuously driving at the same speed, that is 100 km per hour. While driving, the speed of your car may have crossed 100 km per hour, or it may have fallen below 100 km per hour. Means the speed of your car may uh, it can be 130 or 120 at some instant, or it can be 50 or 60 at some instant. So at that time, at any particular time, the speed of a car that we can see in the speedometer, okay, in the car or in a bike, that speed is actually the instantaneous speed. So instantaneous speed is the speed calculated by the speedometer in a vehicle at any given at any instant of a time. Okay, at even any given time. And a body is said to have constant or uniform speed if it travels equal distance in equal intervals of time. Means if a body is traveling in a uniform motion, then of course the speed is going to be uniform speed. I think, is it clear? Now let us understand what is velocity. We know that like speed was distance by time and velocity is displacement by time. Okay, the definition says that the rate of change of displacement of body with passage of time is known as velocity of the body. Okay, the SI unit is going to be same, that is meter per second, and the formula becomes velocity equals to displacement by time. It is almost similar to the speed. The only difference is for calculating speed here we were mentioning distance, but for calculating velocity we are using displacement. Okay, so displacement is also calculated in meter and time in second, so the unit becomes meter per second. So this is how we got the formula for calculating the velocity. Now when a velocity of an object changes at uniform rate, it means what? If suppose the velocity of a body is changing at uniform rate, means at every second it is increasing by 5. Okay, means for suppose for the first 5 seconds the speed is 10 meter per second, then next 5 seconds it becomes 20, then in next 5 seconds it becomes 30. Means it is increasing by 10 10 10 at every 5 seconds. For such a motion, the average velocity is calculated by taking out the arithmetic mean of initial velocity and the final velocity, and hence the formula becomes average velocity equals to u plus v upon 2. Okay, here what is u? Here u is the initial velocity of the object and v is the final velocity of the object. Okay, so this was about these are the two formulas for calculating velocity and average velocity. Okay, now let's move to the numericals that are based on speed and velocity. Here the question is, an object travels 16 meter in 4 seconds, then another 16 meter in 2 seconds. We have to find the average speed of the object. Now, as we have to find the average speed, the formula is total distance by total time. So first we need to calculate the total distance. So that can be calculated by 16 plus 16, that is 32 meter, and total time is 4 plus 2, that is 6 seconds. We simply have to put these values in the formula and we will get the answer 5.33 meter per second. So this is the average speed. In the next numerical, it is given that Usha swims a 90 meter long pool. Okay, here is a pool which is 90 meter long. She covers 180 meter in 1 minute. Here it is 1 minute, means that is equal to 60 seconds. By swimming from one end to another and back along the same path, in the straight path. It means suppose she started from here, so she swim to the other end, and again from there on the same path she returned back to the same point. Okay, means she returned to the same point. Now suppose say she started from point A and she has again returned to point A. Okay, so because she has reached the same point, so we can say that displacement of Usha is 0 meter, because what is displacement? It is actually the distance between initial and final point. But here both the initial and final point is same for 1 minute, because she has reached again the same point. But what is the distance? Distance is the total distance covered. So it is 180 meter. Okay, 90 meter covered while swimming from A to B, and other 90 meter covered while swimming from B to A. So let us first calculate the average speed. It is total distance by total time. So that is 180 by 60. On dividing we will get 3 meter per second. So this is our average speed. Now formula for velocity, it is displacement by time. Okay, just here though, because the initial and final velocity is not provided, we can use that formula of velocity, that is displacement by time. So because the displacement is 0 and the time taken is 60 seconds, that is 1 minute has been converted into seconds. So again it is 0 by 60, it is 0. So the average speed of Usha is 3 meter per second and average velocity is 0 meter per second. So this is how we have to solve the average speed and average velocity. Okay, you can try out few more questions from your textbooks, and if you have any doubt you can just comment in the comment box and I will get your doubt solved. Hope you understood the video. If yes, then you can watch the other videos in the playlist and just subscribe the channel to get more videos.